We are now in week 7 with chapter 7 and module 7, where we talk about disaster recovery tools. So let's talk about Hyper-V Replica for a second. This is a great disaster recovery tool. If you have Hyper-V installed, you've got a virtual machine installed, then you want to have some sort of failover if you're not using true clustering. So I had a customer one time where they bought a server and I virtualized all their physical servers and then I moved them to this Hyper-V host. And everything was great. But I said to them, just to let you know, it's a bit of a risk leaving these servers where they are on a single server. If you have some sort of a crash, then you may want to have a replica server so it has a copy of everything. And about 3 months in, a couple of the RAM sticks went bad. And so sure enough, the host server went down, the virtual machines went down with it. I went over, I found the bad RAM sticks after doing some tests. And after I brought it back up without those 2 RAM sticks, everything was working fine. So I reminded the customer that, hey, this could happen, and it's a good idea to get a second server where we can replicate all of this data. The customer said, well, you clearly caused this problem, so you could sell another server. And that wasn't the first time that someone had accused me of sabotaging them so I would make more sales. And I assured them that that wasn't the case, and I showed them the 2 bad RAM sticks, and there'd be no way I could possibly do that remotely since I haven't stepped foot in the place since I had done the installation. So finally, after some convincing, they understood that it was just bad luck. Anyway, after about another month, they decided to go ahead and buy the second server. I set up replication, showed them how to use it. It's not as automated as clustering, which automatically fails over from one server to another, but it's close enough. So if one host server goes down with the virtual machines, you go to the other virtual machine host, and then you go ahead and you right click and say, go ahead and make this now the primary virtual machine, and then you start it up. So it's not great when you're so good at your job that you predict when something is going to happen and then it actually does. Another time it happened when I was hearing the clicking of a hard drive, which is always a bad sign that a hard drive is going to fail. And I said, this hard drive is going to fail. And sure enough, 2 days later, it failed. And once again, they accused me of causing it. So some customers, there's just no way that you can really work with, but that does happen. So Hyper-V Replica is going to have at least a couple of different servers. One server is going to be the one that's hosting the server, and the other one's going to be the copy that's going to sit in another Hyper-V host server. And it works in a similar way if you're using VMware ESXi. It works with other types of virtual machine hosts as well. And so what you'll want to do is go ahead and set up that Hyper-V host with the virtual machines on it, and you enable the replica portion to work with the other server, and then you can have a password that both servers know, so that way they can trust each other, and then you can go ahead and turn on the replication. So the data is replicated from one server to another byte for byte, but the replica is not turned on. The replica is a virtual machine that's turned off, waiting to be turned on when you have an outage on the original host server. And then you can go ahead, like I said, and right click on that virtual machine that's turned off, that's the replica, and just go ahead and say fail over to this virtual machine, and then it starts working. It's actually very good. I've used it successfully in many different clients over the years who decide to, buy that second server, and I've never seen anybody who was sad that they had purchased it. However, I did have at least one client who bought a replica server that wasn't as high quality as the original. And the problem with that is that when you go to turn on the replica when the primary fails, then the virtual machines run very slowly. You have to use less RAM and less CPU resources, things like that, and then it runs pretty badly. And so you want to get that original one back up as soon as possible so everybody can continue doing their job. So for the plan for the replica, you've got the replica server, connection parameters, you got to enable replication, replication of the virtual hard disk, so you have to have enough storage space on the other server. Frequency, you can have it replicate right away. You can do a delay if you're worried about cryptoware, ransomware, that kind of thing. So that way you have some time to go ahead and restore before it was cryptoed. And then you can also turn on recovery points. So recovery points, just like you would say on a Windows 10 or 11 computer, you can do a restore point. Well, you can do the same thing with virtual machines. So if you do decide to do live replication, where you don't have that pause between replication, then what you can do is you can say that you've got a recovery point, just like a checkpoint in a virtual machine. You go back in time if you need to. The only risk you run is if somehow the hacker gets in the network and deletes those recovery points as well, which is a valid concern, but I've never actually seen it happen. The replica feature is part of the Hyper-V role. So if you've installed the Hyper-V role on a couple of different servers, then all you have to do is turn that feature on, and then that replica broker will start working. You can also set this up in a cluster as well. So let's say you've got 2 server nodes running Hyper-V, and you've got the servers running where one server is hosting the virtual machines, that server goes down, and then it fails over to the other one. Well, if you have a replica of that virtual machine on another Hyper-V server, which I have had some customers do, then that gives you an additional protection in case something happens to the working virtual machine. So you can do this on a standalone Hyper-V host, or you can do it on a cluster. You can also check the status of the replication. You can do that either through PowerShell, command prompt, or you can just right-click on the virtual machine and go to Hyper-V Replica and just click on status. And if there's a problem, it'll either be a yellow triangle that there's an issue, or it'll be a red circle that says that Hyper-V replication has broken, and then you'll have to fix it. So when you're ready to use your replica that's sitting just in as a turned off virtual machine that's being updated every time there's a change to the live one, then you can do a few different things. Or you can test the failover to see if the failover will work. You can do a planned failover where you plan the failover at a certain day and time, or you can just go ahead and do the failover right then and there. So if you do the failover and you boot up this other server, then when the original server comes back online, you can fail back to it if you want to, or you can just keep working in the failover replicant. There may be times when you need to pause replication, like when you're doing Windows updates or something like that. And then once you're done pausing, you can go ahead and right-click on the virtual machine and choose to resume replication. And as I mentioned earlier, you can look at the replication health. You can extend the replication or remove recovery points if you decide you're running out of space. And then you can also just delete replication altogether if you feel you no longer need it. Another tool you can use is Azure Site Recovery. So organizations that want to have this business continuity, that's where the continuous use of your server resources is always there. And also disaster recovery in case you need to restore from backup. So you have these processes set up to ensure that your business always continues to use those servers as needed. So there's multiple different ways you can do that. There's a site recovery using the business continuity and disaster recovery solution, where it can replicate on-premises virtual machines and physical servers to Azure. So instead of having a second physical host running Hyper-V, you could have another server in the cloud and have that be your replication location. And then when you need it, you can just turn it on in Azure. So that way you wouldn't have to buy a second physical host computer. You would just rent it at Microsoft Azure. Which way is more expensive? It's really hard to say. It depends on the use, how often you back it up, how much space it's using, because you get charged by how much space you're using at Azure, and what kind of workload that it has on it. So in some cases, it might be cheaper to buy a second host. In other cases, it might be cheaper to stay with your replicant on Microsoft Azure. So live migration, this is something in the Hyper-V role when you're going to be doing a cluster. So when you have your cluster set up, then you can do a live migration from one server node to another server node while it keeps the virtual machine up and running. And it's a really nice feature that you can use. So there's lots of different requirements in order to make sure that this works right. I've had it work flawlessly in some cases. In other cases, I had to troubleshoot it. And this feature is only going to work in a cluster, a Windows Server cluster that has 2 or more nodes running Hyper-V on them. So you've got to have the hardware that supports virtualization. So they have to both have Hyper-V installed on them, and it has to be working. You have to have processors from the same manufacturer. So in this particular case, you need to have a matched pair of host servers where you've got the same RAM, the same processor, the same motherboards, the same storage type. Now, in normal clustering, you don't have to have that. You can have one server node be slightly different than another server node, as long as you have the same network interface cards and drivers. But when it comes to hosting a virtual machine, they should be matched pairs. It's possible to get it work without matched pairs. It's just not likely. So it's a good idea to have that. And then you can do a migration from one server to another. So why would you need to do a migration? Well, if one server node needs to go down for maintenance, or if you feel like that server may not be running properly, then you can manually move it over or just set it for automatic movement to using live migration in the cluster manager. And so if it feels like, uh-oh, this server's about to crash, then it can just move itself. And even if it does crash, it can still automatically move from one server node to another. And that's because the storage is all on the shared storage in the SAN. It's not on the server nodes. So it doesn't really matter which server node is hosting it as long as one of them is up and running. The source and destination computers should belong to the same Active Directory domain, or if they're not, they need to be in domains that trust each other. So remember, you can set up trusts between 2 domains in the same forest, or you can have domains in separate forests, like you would see in mergers and acquisitions, can trust each other, and then that would work as well for that migration. Now, if you're not using clustering, it's still possible to migrate the storage from one server to another. So you can basically just right-click on your virtual machine, say in server 1, and tell it to migrate to server 2. So in that particular case, it's actually moving storage. It's not staying in the same location. Now, in clustering, you can move virtual machines to different storage as well, as long as it's shared storage that both server nodes, 2 or more server nodes, have access to. Let's move away from Hyper-V just for a little bit here and talk about Windows Server Backup. Windows Server Backup is a feature that you can install in your Windows Server, and it's included in all versions of Windows Server. And you can use multiple different types of storage media, such as a DVD. You can use internal storage on a different drive. You can use a SAN. You can use a network share. Lots of different places where you can use your storage for backing up your server. Now, Windows Server Backup only works on one server at a time. So if you have multiple Windows servers, then every one of those servers is going to have to be set up with Windows Server Backup. You can back up all volumes, selected volumes, certain folders and files, the system state, which is what you'll need to bring the server back to its original state. So that means the same drive letters, the same Active Directory, the same registry, applications, all those kinds of things. The system state is required as part of that. Individual virtual machines also can be part of the Windows Server Backup, as well as Microsoft Exchange Server, cluster shared volumes, SQL Server, lots of different things can be brought back. Basically, everything can be brought back if you do what's called a bare metal backup. A bare metal backup means you can move the entire server to another piece of bare metal or another server. So to implement backup and restore, there are different procedures. You can do one-time backup, or you can do a scheduled backup. Of course, the scheduled backup is really the way to go. Now, besides using Windows Server Backup, you can also back up certain things within the application. So, for instance, you can back up group policy objects. You can back up the configuration for Internet Information Services, the certificates, all different kinds of things. But it's really better if you use a backup program to do that, because the backup program is going to cover all that all in one swoop rather than doing it individual pieces. And you can also do PowerShell to back up specific pieces as well by using the Windows Server Backup. Now, you can also back up Active Directory domain services. So your Active Directory database, that's part of the system state. So as long as you back up system state on a domain controller, it's going to cover that. Now, the full server backup contains all the volumes on the domain controller. You can perform a system state backup separate from that, or just have it included in the full server backup. Now, once the server does its full backup, if you do a scheduled backup, the second night or day or whatever it is you're running your backup, it's going to do what's called an incremental backup. An incremental backup is going to back up any files that have changed since the last backup that happened. So on Monday, let's say you do a full backup. On Tuesday, it'll do any files that have changed since Monday. On Wednesday, it'll do any files that have changed since Tuesday, and so on and so on and so on. Eventually, it will need to do another full backup later on, and then the process will start all over again. Now, you can also set to decide how long you want a backup to stay on the drive before it gets overwritten. So you just have to decide what your retention policy is going to be. A retention policy just decides how long you're going to, keep that data before it's overwritten. You can also back up Microsoft Exchange Server. So I'm assuming that you have Microsoft Exchange Server 2019 or 2016 or something like that. And you can back up all the different databases and restore when necessary. I've had many cases where Exchange Server became completely corrupt and we had to restore from a backup in Windows Server Backup to get everything working once again. Windows Server Backup is also aware of what's called Volume Shadow, the Volume Shadow Copy Service, or VSS. And Volume Shadow is important not just with Exchange Server, but with all files. So if there is an open file, such as what's being used by the operating system or by an application like Exchange or SQL, or even a Word document or Excel document that's shared on a file server, what it does is it doesn't back up the file that's open. The server backup makes a copy of the file that's open, and it backs up the copy. And that's because if you try to back up a file while it's in use, a live file, then you could easily corrupt it. So it's much better to have the Volume Shadow service just make a copy of that backup instead. Now, you can exclude files and folders as well. You don't have to do a full backup. You can choose specific files and folders if you'd like. When Microsoft Windows Server Backup does a backup of a virtual machine, it creates a copy of that VHD or VHDX file. So instead of doing a restoration of the virtual machine, you could just grab the VHD or VHDX file and just move it into another server running Hyper-V and then just boot it right up. I've done that many times. Once your data has been backed up, you can go back in and do a restoration whenever you need to. Now, if you're using brand new hardware because your original hardware failed, then you would just attach, say, a USB drive or whatever was your backup media, and then you would plug it into the new hardware, and then you can boot off of, there's a bootable DVD where it allows you to restore from backup. So it will connect it to your backup drive after booting off of the DVD, and then it will find it and do your restoration for you. But in most cases, you're going to want to do a restore of specific files and folders that were deleted. And that's a pretty easy thing to do. You just run the Windows Server Backup, run restore, select the files and folders, choose next, and finish. And you'll be doing just that in your lab for this module. Azure Backup works in a couple of different ways. You can either send your backup using Windows Server Backup off to Azure, and you can send it there so it's being backed up there, or you can go the opposite direction. You can take your Azure resources and back them up to your local on-premises servers. So either way, you can do that. You can also back up Azure to an Azure service in the cloud. So all different directions of backups will work between your Windows Server and Azure. Some of the advantages with Windows Server Backup include automatic storage management, so it'll overwrite the oldest files when needed. Unlimited scaling, meaning you can scale up to as many hard drives as you need, as much storage as you need, just keep attaching more storage, and it'll keep backing it up. Multiple storage options, so you can, as I mentioned earlier, you can store it to a share, you can store it to local storage, whatever you want. You also have the option for encryption, offload on-premises backup if you need it, and then backup for Azure, and you can choose your retention time. If you'd like to use Microsoft Azure Backup, then you have to install an agent that comes from Azure, and then you'll have a trust that's configured between your computer and the Azure Backup, and then you can go ahead and run those backups right into Azure. There's also a procedure to make a drive letter show up at Azure on your Windows server. So basically you use a combination of the key and the name of the backup storage that's in Azure, and then you run a command on your Windows server and make it the G drive, for instance. And now the G drive, instead of pointing to a local location, is actually pointing to Azure. But the Windows Server Backup can't tell the difference between local and remote. So it'll just tell it to run the backup to the G drive. Okay, it'll do that. And instead of locally backing it up, it's actually backing it up to Azure. So in this module, we talked about all different types of recovery tools and ways you can keep your virtual machines going, as well as being able to back up and restore your physical servers and local virtual machines as well. And that will do it for Module 7.